In this video, I'll be going over 3.4 equations of lines. The goal here is to write an equation of a line, given information about the graph, and solve problems writing equations. So you can write an equation of a line if you are given any one of the following. So you only have to be given one of the following statements. So if you're given a slope and a y-intercept, if you're given the slope and the coordinates of the point on the line, if you're given coordinates of 2 points on the line. So if you're given any one of these, you're able to find the line of an equation. So just a refresher here, we have your slope formula at the top right. We also have a graph here, and I just wanted to refresh your memory. So remember here that slope is the change in x, the delta means the change, so the change in x and the change in y here. So the slope is the change of y over the change of x. So we'll subtract our two y coordinates, find the value, subtract our two x coordinates, find the value, and then you have your fraction, and of course you can simplify it. Now here we also have our y-intercept. Remember that wherever our line intersects our y-axis, that is your y-intercept. And the way that you write that is 0b. B is known as your y-intercept. And then additionally, just to refresh your memory here, we have our x-intercept. I just labeled it as h. You can put any letter here or any number, but that is our x-intercept. I'm sorry, that is our x-intercept. And your x value goes in here, and your y value will always be 0 for your x-intercept, whereas for your y-intercept, your x value will always be 0 on your y-axis here, and then you'll have a different value for b. So what your notes say here is if m is the slope of a line and b is the y-intercept, the slope-intercept form of the equation is y equals mx plus b, and the point-slope form of an equation is y minus y1 equals to m times x minus x1. And I believe you've seen those both before. Your slope-intercept form, which is y equals mx plus b, and then your point-slope form, which is y minus y1 equals to m times x minus x1. So you've seen both of those before in the past. Now, down below we do have an example. We have the example of slope-intercept form, which is of the form y equals mx plus b. And so here I asked you to write an equation in slope-intercept form if a line with slope 2 has a y-intercept of 4. And so remember here that your slope is m, and your y-intercept is b, so you have m and b, so you can just plug them into your equation, y equals mx plus b, so y equals negative 2x plus 4, so that will be your equation there then. That is your answer, y equals to negative 2x plus 4. So here, looking at our first example, we have the same process. We have an m and a b, and I asked you to write it in slope-intercept form, and so that's y equals mx plus b, so you'll just plug in your m, and you'll plug in your b. And then that gives us y equals to 2x minus 3. The next thing that I asked you to do for this problem was to graph it. So you'll graph your y-intercept, so you'll graph negative 3. So you'll graph it right here on your y-axis. And then your slope is 2, so it's a positive 2, so you don't have a positive line, so you'll go up 2 and then over 1. And then you'll continue up 2 over 1, up 2 over 1. And then as always, you will connect your dots, hopefully drawing a better line than I did, but there's your line. Now moving on to number 2. Here you have 2 points, and so now instead of me giving you the slope, you'll have to find it, so that's what I did here. I have 2 points, I have 0, 3, and negative 2, negative 1, so we'll go ahead and plug those two coordinates into our slope formula, which is y2 minus y1 over x2 minus x1. And so when we plug those in, again, our first coordinate that we have here is 0, 3, and I had that one as being my x1, y1, and then the second one that I had was 2, negative 1, which I had as being my x2, y2. So I plug them in here. We have y2 minus y1, and then we have x2 minus x1, and negative 1 minus 3 is negative 4, negative 2 minus 0 is negative 2. Then we'll simplify our fraction. Negative 4 divided by negative 2 is a positive 2, so that's my slope. And then we have our b, where I actually gave you your b. You have to look at your problem here, what I originally gave you, and which was 0, 3. So that is my y-intercept. And if we graph that on the graph, we'll find 0, 3. So it starts right there. And so there is your y-intercept, and you can go ahead and make your equation using your slope and your y-intercept, which is 3, and then you can go ahead and graph it. So I put my y-intercept there already, and then we'll go down 2 over 1. So down 2 over 1. Again, this is a positive. Down 2 over 1, down 2 over 1. And I went down. You could go up if you like, go up 2 over 1. I just went down because there's more room in that direction. The goal here is to focus on whether or not your slope is positive. So next we'll look at our second formula that we have, our second type of equation, and which is point slope form. And so here it's actually in the title. The other one is called slope intercept form. So you're given a slope, you're given the y-intercept, and this one is called point slope form. So what you're given is obviously a point and a slope. So that's when you'll use this formula. And so over on the rest of the problem on the example, it says write an equation in point slope form with the slope of negative 34, and that contains the point 8, negative 1. And so you do have your slope here ready. So that's your m, and then you have 8, 1. Well, that's your point. That's your x1 and y1. And so what we do here, this is the only space really where students sometimes get confused, is you have x1 is 8. That's what you're plugging in. So that goes in for your x1 there. And then your y1 is 1. That's your y1, and so that goes in for your y1 there. So you will have a variable in your equation always. You will always have a y and an x. Even if you're using your y-intercept formula above, you will have still an x and a y. So it's important that you remember that. Some students, sometimes they get confused and they'll plug in their points into a different location, but your point goes into x1 and y1 here. Now, with that being said, you've already set up your equation. There it is. You plugged in your point and you plugged in the slope, so you're good to go. So you have y minus 1 equals to negative 34, x minus 8. So that is your equation. Again, your slope was negative 34. So now we'll take a look at your problem number 3 here. And so again, I gave you your point and your slope. And so you'll plug in your point. You have x1 and y1. So here is your x1 and your y1, and you'll plug them into your function, which they go in here, x1 and y1, giving us 3 and negative 1. And then you'll plug in your slope, and your slope was 1/2, which is why it went here. Okay, and then you will leave it like that. And now the only thing that we simplified here was this double negative. I made it a positive, but you can see here everything else stayed the same, and that is your point slope form. Now, whenever you're graphing, you can simplify it and put it into slope intercept form, or you can just leave it as it is. So we'll start with graphing our coordinate, which is 3, 1. So we'll go over 3 and down 1, 3, negative 1. And then our slope is a positive 1/2. So you can go up 1 and over 2, or you can go down 1 and over 2, whichever direction. You just want to make sure that your slope is positive, because here we have a positive 1/2. So up 1 over 2, or you can go down 1 over 2. Wherever you have room on your graph is what you're looking for to make sure that you are graphing your graph correctly. And then you will draw your line. So now looking at your fourth problem, you have the same process here. You have a point and a slope, and I'm asking you to put it in point slope form. So you have 4, negative 2, and we'll plug that in for x1 and y1, and then you have your slope, m negative 2, and we'll plug that in as well. And the only thing we had to simplify, sometimes you won't even need to do this step, but we have a double negative, so we'll simplify that to a positive, and then we'll go ahead and graph our equation here. And so we have the point 4, negative 2, and our slope is a negative 2. So in this case, our line will be going in the other direction. So we'll go up 2 over 1. We'll go this way. And up to, over 1, up to, over 1. You can go down to and over 1. You just want to be sure that you are graphing your line correctly. And then, of course, you'll draw your line as straight as possible. So now the next thing we'll go over is horizontal and vertical lines. So the equation of a horizontal line is y equals b. And the reason why it's y equals b is because if it's a horizontal line, it goes through the y-axis. So that's how we know it's y equals b, where b is the y-intercept. Next, we'll take a look at vertical lines. And so vertical lines are x equals to a. And so here we have a vertical line, and it's because they go through the x-axis here. And so that's why when we write our equations, we have x equals, and then whatever value, it goes through the x-axis. And of course, a is your x-intercept of the line. So for number 5, you're going to write an equation of a line through -3, -2, and -3, 4. And so first you will write the equation in slope-intercept form. And so in order to do that, we have to first find our slope. So in finding our slope, we'll discover that it is undefined. So here we have 4 minus -2 as our y1 minus y2 here. 4 minus -2, and then we have 3 minus -1, and when we simplify that, we'll get 4 plus 2, which is 6, and -3 plus 3, which is 0, giving us our undefined value. Now, remember that undefined are vertical lines. When our slope is undefined, it's a vertical line, and we learned that in our previous set of notes. And so here, since we know it's a vertical line, we'll simply write x equals to -3. Again, remembering vertical lines have the equation x equals to a, whatever the x value is. And here you can see a quick reference or a quick clue to whether you have vertical or horizontal line is, again, remember your x's will be the same if you have a vertical line. Your y's will be the same if you have a horizontal line. And so now let's take a look at our next problem, which is problem number 6. And in here, you were to write an equation in slope-intercept form for a line perpendicular to 1/2 x plus 9, containing point B, which is -7, -4. And then you're going to graph both lines, graph the original line and then your new line that we'll find at the end. And so we know that our first clue here is that it's perpendicular. So we want our slope then to be perpendicular to this. And so our original slope is 1/2. So therefore our perpendicular slope will then be -2 because it's the opposite reciprocal. So that's our slope that we'll use for our function. And our original problem said to put it in slope-intercept form. Slope-intercept form is y equals to mx plus b. Now, with that being said, we can't put it in y equals mx plus b because we don't know what our intercept is, what our y-intercept is. So we have to find it. We can do it one of two ways. We can plug it into here and find it. We can graph it. We can plug in 0 in for our x and solve. There's a number of different ways that we can do it, but the way that I'm going to show you how to do it is to use your slope point formula to go ahead and find it. And so what we'll do then is we'll use our slope point formula here, and then we'll transfer it, we'll manipulate it, we'll solve for y so that it will be in y equals mx plus b form. So I went ahead and I plugged in 2 in for m, and then we have our point, and in this case our point was b, which was -7, -4. And so I plugged that in for x1 and y1. And then I simplified. So we have a double negative here, giving me +4, a double negative giving me a +7, and then I went ahead and I distributed in to my equation my -2 there. So I distributed that all the way in to all of my function. I multiplied them out. So after I distribute that in, I got -2 x minus 14, and then I went ahead and I continued to solve for y because it needs to be in y equals mx plus b. So I subtracted 4 from both sides, giving me negative 18, which resulted in our final answer here at the bottom. Now, again, remember that this is the form that I had asked for in the beginning here. That I asked for slope-intercept form. So when you're solving problems, be sure that you are answering questions. Be sure that you are putting it in the proper form that I am asking for. The other thing that I asked you to do was to graph both lines. So we want to go ahead and graph them on the right-hand side. So in graphing our first equation, I went ahead and I plotted my y-intercept, which is 9. And then my slope was a positive 1/2, so I went down 1 over 2, down 1 over 2, down 1 over 2. And then for our second equation, I have b is negative 7. So I graphed my b here as negative 7, 4, negative 7, negative 4. And then I know that my slope, my new slope was negative 2. So it's a negative line. So I went up 2 over 1, up 2 over 1. And our graphs do intersect, but a little bit off our coordinate plane here, but that's okay. You just need to see that they are perpendicular or form a right angle. So just to review our notes, you do have two types of equations. You have slope-intercept and slope-point form. Additionally, you have two types of lines. You have vertical and horizontal lines, and then you also have non-vertical or non-horizontal lines, which are any other angle other than vertical and horizontal. And so when you do have a horizontal line, your equation is y equals b. When you have a vertical line, your equation is x equals a. And your slope-intercept form is y equals mx plus b, and your point slope form is y minus y1 equals to m times x minus x1.